In this tutorial, we will create a dissolution effect using movement. We will start by creating a new compo in which we will create a 3D plane, as well as a camera that will face the plane. We can click on this icon to make the camera the viewpoint of the compo. We will rotate the plane by 90 degrees so that it faces the camera, and resize it to match the same aspect ratio as the camera. We can position the camera at the right distance to ensure the plane fits perfectly within the frame. On this plane, we will apply a modifier Emit Particles. We can delete the surface renderer so we can see the plane, keeping only the point renderer to display particles. In the default points renderer, we can lower the size parameter to make particles smaller. Now, we will need to use a video input to track movements. To achieve this, we need to set up a video input. Let's open the Preferences panel of SMODE in Edit Preferences, or by pressing the F11 shortcut key. In the Preferences panel, under the Video Input section, I will add a new video input by clicking on Add. As for me, I will choose the integrated camera of my laptop. We click on Apply Changes to ensure the changes are properly applied. We can close this Preferences panel and check in the Devices panel that the video input has been successfully created. We see real-time information coming through. We can now create a video input layer in the compo. I will resize this video input and flip it since it's currently mirrored. What we will focus on in this video is detecting movements in order to dissolve the text when we do, for example, a movement with the hand. To do this, we will use the Optical Flow modifier. We will increase the number of iterations to the maximum, and now we can see that if I move my hand, the movement is detected. We will use that to influence the particles. We will add a field to the particles, and we will select Normal Map Texture Layer. I will disable this video input for now, so we can see the particles. So we will have a normal map as input, which will determine the direction the particles will take. We can increase the size to 10 meters to clearly see the deformation, and increase the force strength to 100. I will raise the particle emission rate to see better what's going on. The particles are being diverted by this normal map, which currently contains a linear gradient. But what we want is to take as input the video input layer. So I'm going to select the video input, and I will add the optical flow effect. If we stay still, there's no deformation, but if we move, we can see that it affects the particles. I will move this video input behind the plane so we can see the movements. To achieve the text dissolution effect, we want the particles to be emitted solely on the letters of the text. To do this, we will place a mask of type layer on the particle emission. And instead of a uniform, we will select a text. For now, the text is very thin, so it's hard to see the text on display. So we will change the font size to 200 and set the text to bold. At the moment, the particles have an initial speed, which makes it quite difficult to distinguish the display text. So we will remove their speed so that the particle stays at the same place. I will also increase the particle rate so we can see better. This way, I can distinctly see the text on display, and if I wave my hand, I can see the dissolution effect. To avoid the text disappearing by accident when the person moves, we are going to place the text in a place with a uniform background, so I'm going to place it over here. To do this, I will add a 2D transform. And we can also add a colorize modifier for better visibility on the light background. Currently, the problem is that even when the text is dissolved, it will appear again behind. To avoid this, we will go into the particle emission settings, and we will change the emission rate to 0. and choose to emit particles manually whenever we want. So we will add a large amount of particles that we will emit just once, and when we make them disappear, they won't appear again behind. So we have recreated this effect of text dissolution.